Yeah, you're like, really? Really? Yeah. Yeah. Okay. So suppose I have a demand curve. Let's optimize this function. So I'm going to find total revenue. This is P. I'm going to multiply P times Q. So I'm going to get 1400Q minus 7.5Q squared. I'm going to take the first derivative of that, and I'm going to get 1400 minus 15Q. I'm going to set that equal to 0. Okay? This is, remember, this is marginal revenue, right? So I'm setting marginal revenue equal to 0. That's the point where we maximize our revenue. Q, P, there's the demand curve. Marginal revenue curve goes like that. There's a marginal cost curve. That point, yes, A is max profits. That point, call it B. B is max revenue. Oh my. Okay? So we can't just separately maximize these equations. We can't separately maximize our revenue and minimize our cost and find profit. It doesn't work that way because we need the two of them to be equal. We need marginal revenue and marginal cost to be equal. So let's max our profit here. We already know that total revenue is this, right? That's total revenue. And we're going to subtract total cost, and we're going to make up total cost as this. Okay? So we're going to take the partial, or it doesn't have to be the partial, could be of the profit function with respect to Q, right? And so we just go down the list. That's 1400 minus 15Q minus 3Q squared minus 12 plus 12Q. Sorry. Plus 12Q minus 14. And we set that equal to 0. So now we clean this whole thing up. We get minus 3Q squared minus 3Q minus 15 plus 12 is a minus 3 plus 1386 equals 0. I can divide this whole thing by 3. Yes, and so I get minus Q squared minus Q plus 462. 462 equals 0. Now I say minus b plus or minus the square root of b squared minus 4ac over 2a. And now you're really thinking, why did I take this class? Yes, that's minus 1 plus or minus square root of 1 minus 4 times minus 1 times 462, all that over minus 2. Yes? So that's minus 1 plus or minus 43 over minus 2. Ooh. So that's 42 over minus 2, or minus 44 over minus 2, which is minus 21 or plus 22. And those are the solutions. We're not going to take Q equals that. We're going to throw that out because it's a negative number. We don't use negative quantities, and that's our profit maximizing quantity. Q equals 22. Okay? Now, he said, we could come back to this thing again and take the second derivative, right? And we simplified that equation down to this. So we've got the first derivative was what? Minus q squared minus q plus 462. Yeah. So the second derivative is going to be minus 2q minus 1. Yes. Q greater than 0 minus 2q minus 1 has to be negative. Do we see that? A little bit of math there. If that's a positive number, this whole thing has to be negative. Yes? So our first order condition is good, right? We set fx is equals 0 at 22. And our second order condition, as long as q is greater than 0, minus 2q minus 1 is less than 0. So we have our both satisfied, both our first order and second order conditions are necessary and sufficient conditions are satisfied. And we have just solved and saved the world. Yes? Okie dokie dokie. Just for fun, let's do a couple just simple things, yes? Because fun, yes? No? Yes. So let's find the optimal point here, optimize this function. To do that, first we need, first derivative, which is going to be minus 18x plus 72. We set that equal to 0. Yes? So 72 equals 18x, x equals 4. Do we like that? 4. So x equals 4. All right, now, the first derivative was what? Minus 18x plus 72. So the second derivative is going to be minus 18, which is less than 0. Therefore, we have a maximum. Okay? It's also concave, by the way. If you care about that, it's a concave function because this is less than 0, but kind of the same thing. Yes? Okay. So let's do this one. Now, it's not very complexical, but it illustrates is a point for us. So we say first derivative, which is going to be 3x squared. We're going to set that equal to 0. That means x equals 0. That's the optimal point, right? The only way that this thing is equal to 0 is if x is 0. Okay? Now, second derivative equals 6x. Well, 6x could be greater than 0, equal to 0, or less than 0. So because it has this 0 thing in it, we're going to hippity skippity bippity bop, and we're going to look for the first non-zero, right? The first non-zero, right? Because if x is 0, 6x equals 6 times 0 equals 0. We need the non-zero, right? So the third derivative is 6. That's the first non-zero derivative, but third is odd, right? The number 3 is odd. So this is a third derivative. The first non-zero derivative is an odd derivative. That makes this an inflection point. Okay? So the second derivative was 0. We look for the first non-zero derivative. That happens to be the third derivative. And because 3 is odd, it's an inflection point. If we draw a graph of this function, it looks like that. And so there's 0, which is in fact an inflection point. X equals 0, it's an inflection point. Okay? Or actually, it looks like that. But you know what I mean. You know what I mean? You know what I mean? You know what I mean. No? Yes, just say, oh, I get that. I know what you mean. No? Okay. So let's try this. Let's say we have a profit function, and again, that's a q, minus 13q squared, minus, and that's total revenue, and then I need to minus total cost, which is q cubed minus 5.5 q squared plus 150q plus 675. Okay? So I need to take the first derivative of this. And I can just mark it like that, right? I can put the, put the little prime there, and that means the first derivative, as we all know. And that's 4350 minus 26q. Yeah. Yeah. Minus 3q squared plus 11q plus, that's a negative 150. Okay? So that's going to be a negative 3q squared minus 15q. Yes? No? Yeah. Plus, what else do we have here? 4,200. How's that? Does that look good? Okay. So again, minus 3q squared plus 15q. We put that into the, minus b plus or minus square root of b squared minus 4ac over 2a. And we either get q equals minus 40 or q equals 35. Do we want to do that, right? It's minus a minus 15, so it'd be 15 plus or minus 15 squared minus 4 times minus 3 times 4,200 over 2 times minus 3. And we either get minus 40 or plus 35. We're going to throw out the minus 40 because, I don't know, again, businesses don't sell minuses. It's a meaningless concept to us economists. So Q equals 35. Q equals 35. And now I had, remember, the first derivative is this thing, minus 3q squared minus 15q plus 4,200. second derivative is minus 6q minus 15. Q equals 35. It's a positive. It doesn't really matter that it's 35. It's positive. Therefore, this thing, 6 times 35, right, is minus 225, which is negative, which tells us it's a max, and it's concave. All right? Is that exciting? It should be. You should be going, dude, I can do these. I can handle them. Okay? It's